Hello, Janvi Porvander. Good afternoon. I hope I am clearly audible to you. If it is all thing is clear, are you able to hear me? Can you please tell me in the comment box? Okay, so yeah, so first of all, I hope you all are very happy after celebrating Diwali. So wish you a belated happy Diwali. Okay. So yeah, so I've just finished one class. So in between these 5 minutes, I was just switching to another account. Okay, so yeah. So welcome everyone. So what we are going to start today? Today the topic is continuity and differentiability, right? So the last few classes, last week also, we have conducted one class. I guess two class. One class is limit complete last theory, that the remaining portion of limits we have discussed, and after that, in the next class, in the Sunday class, we have also discussed few JE problems. Okay, so those videos are there in the YouTube Avanti Live 3. You can go to that you can see the recorded videos also. Okay, whenever you are getting time, you just go through it so that it will won't be having problem going forward. Okay, because when we are studying continuity and differentiability, then we need limit concept. Everywhere you will see there is a concept called limit. Okay, so that's why this is very necessary to have a good command over limit. Okay, so yeah, so without any delay, we will start the class now. Okay, so what we are going to discuss in today's class, the first thing that we are going to discuss, that is continuity. We will see what is the basic definition of continuity and all, and after that we will see the continuity of any function around a point or at a point. Okay, and then we will see continuity and in interval, because when we talk about continuity, so first we will see at a point whether the function is continuous or not, and then after that we will see the entire interval whether the function is continuous or not. Okay, and then we will see reason for discontinuity, means there will be some points where it will won't be continuous, so that point will be called as discontinuous point. Okay, and then we will also see types of discontinuity. Okay, types of discontinuity, we will also see what kind of discontinuity can happen. And after that we will see algebra of continuous function, means what, the plus minus, like if two functions are continuous function, the what will be the nature of the sum of those two functions, minus of those two functions, product of those two functions, divide of those two functions, we will all see. And also we will see continuity of composite and inverse function. So these things we are going to discuss today. Maybe it depends on you or the fluency of me, like depends on you whether, because in the last class I was discussing, so I was about to finish these types of discontinuity. Okay, so let's see kahan tak jate hai, right? Okay, so what is continuity? So very simple thing, what we have to see, that first of all I will explain you in basic language what is basic language actually. So if we can say that any function is a continuous function, so if we are able to plot the graph of that function without lifting our pen from the paper, then that function will be called as continuous function. Like suppose I have a pen, I have a pen tab, I am drawing any graph of any random function, so I am not lifting my pen, so throughout wherever I will it will go, it will be all where everywhere it will be continuous only. So it is continuous because we have not lifted the pen from the paper. But suppose we are again drawing a graph like this, and suppose my pen, I lifted the pen, and then after that there will be definitely a point of discontinuity, and like this. So here you can see it is not continuous. So I hope कि सबको समझ में आ गया होगा कि what is the continuous function in basic language, right? So but what we have to do when it comes to problem solving, we have to just remember this thing, that a function is said to be continuous at x equals to a. We are talking about at any point x equals to a. If function is continuous, it means what? Limit of x tending to a minus f of x, it means it is LHL. I think already you know that left hand limit, and x tending to a plus this is RHL, and exactly f of a पे जो value होता, if all will be equal, then only we can say that this any function is set is continuous at x equals to a, right? This is that condition. So I am just taking one example, one simple example to explain about this, right? So suppose we have a function f of x is equals to x square, okay, and we have to decide, check that whether this function is continuous at x is equals to a or a 1 or not, right? I am saying that key whether fx is continuous at x is equals to 1 or not. Okay, we have to check it at x equals to 1. We have to check whether, we already know that f of x is equals to x square ka graph. So if you are say, if you want to check by the graph also, you can draw like this, right? So you can see that everywhere x square is always continuous, but they are saying that you have to check. So by the process, what I will do, I have to check, right? So suppose the one is here. Okay, so we have check we have to check in the left hand neighborhood and right hand neighborhood, like 1 minus and 1 plus. So first of all, I have to find LHL. What is LHL? It is limit x tending to 1 minus. 1 minus will what? It is 1 minus h. I hope you have seen this in limit also, h tending to 0. So it is x square, or in place of x, I can write 1 minus h ka whole square. So 1 minus 0, because h tending to 0, so it will be 1. Similarly, if I have to find RHL, I can write limit x tending to 1 plus, like this is 1 minus and this is 1 plus neighborhood, and then it will be 1 plus h ka whole square. So it is 1 plus 0 ka whole square. So that is 1. So this is LHL, this is RHL, and f of 1 pe we have to find the value. So you know that f of x is equals to x square. So it will be 1 square. So it is 1. So now you can see that LHL is equals to RHL is equals to f of 1. So what we can get it from here? We can say that that function is continuous at x is equals to 1. Okay. So you can see here also by the graph also it is continuous. Now around x is equals to 1, it is continuous. Okay, just wait a second. Okay, sorry guys for the disturbance. Someone just called me, so I had to take that call. So sorry for the delay. Yeah. and there is no issue because after 5 till 5 I will teach, and after that I will teach till 5:10 also, no problem. Okay, so I hope समझ में आ गया होगा. You have to just find LHL, RHL and F of 1. Okay, so one note is there that you have to remember is that this continuity of a function is basically a property of interval. Means property of interval means what? If we are talking about continuity of any function at x is equals to a, then it is only meaningful when if the graph has immediate neighborhood of x equals to a. It means what? Suppose I am saying that like at a you have to find whether the function is discontinuous or not, or continuous or not. So you can say if I have defined the function in an interval, so you can see left hand side there is no graph, right? But right hand side there is a graph. So in this case we can't talk about, still we will talk, but here you can see LHL is not there, only RHL is there. So it is only meaningful, continuity is only meaningful if it has both left hand limit and right hand limit. Then only we can talk about continuity of that function. There is some exception I will discuss later, but for now just remember that if the graph has immediate neighborhood means what? Left hand side should be there and right hand should be there. Then only we can tell that whether that function will be continuous or not. Okay, so this is a small note that you need to remember. Okay, so there are some function you can see here. One by one I will explain which function is continuous and which function is not continuous. Okay, so here you can see, guys, this is at exactly 3 what we need to find. You can see if we go left hand side, so LHL will be 4, right? If we go right hand side, RHL will be 4 also, and if you will exactly find at 3 f of 3, so it is what? 4. So you can see LHL is equals to RHL equals to f of 3, so it is continuous. I am writing as C. Second, if you will go to the second graph, so left hand side, this side if you will come, so LHL will be what? 4. If you will go right hand side, so this graph suddenly jumped from 4 to 5, so RHL will be what? 5. And f of 3 is what? F of 3 is also 5 because there is a dark here. So that's why f of 3 is taking 5 value. So you can see LHL is not equals to RHL. LHL is not equals to RHL. So what we can say, this function is not continuous. Either you can see NC, yani not continuous, or you can also say DC, yani discontinuous. Right? So this is the case where the function can be discontinuous also. The third case you can see. Can anybody tell me what is the third case? Anyone? What is the third case? Janvi Rajkot, Janvi SKLM. Third case में बताओ whether it is a continuous function or discontinuous function. जल्दी जल्दी से in the chat box. यहाँ पे देखो, graph के through if we will see, guys, so this is left hand side, this is right hand side. Yeah, discontinuous. Very good. Okay, this is discontinuous. Yeah. Wow, very good. So here you can see LHL is equals to RHL, but it is not equals to f of 3 because LHL, if you will see, it is 4. RHL, you will see it is also 4, but f of 3 value is 5. So it is not equals to, yeah. So all three should be equal, then only it can be continuous. Otherwise, it will be discontinuous. So it is discontinuous, right? Similarly, this one, if you can see, so what happened here? So if we will go LHL, so you can see that this is going till infinity. So you can see LHL is tending to infinity and RHL is also tending to infinity. Okay, and at f of 3 it is also tending to infinity. So in this case, when we don't have any finite quantity, so we can't simply say that LHL is equals to RHL equals to f of 3. So this kind of thing is also discontinuous because it is not getting very finite value, because we are not sure. It is tending to infinity, so we are not sure about it. So that's why this is also discontinuous. And here you can see LHL is equals to 4, RHL is equals to also 4, but when we talk about f of 3, there is no value. Okay, there is no value we are getting. It means what? F of 3, we can say it is not defined. By looking at the graph, you can't find the value of f of 3. Here there was a value that was upper, but here there is no value, right? So in this case it is not defined. So in this case also we can say that it is discontinuous. Okay, so I hope you must have got idea about which type of function is continuous, which type of graph is not continuous. So these are the some cases where you can find that key whether the function is continuous or discontinuous. So the only condition is that LHL should be equals to RHL and it should be equals to f of a. It means at that around that point where we are finding the continuity. Okay, I hope it is clear to all of you. Okay, so there are few notes that you have to remember, guys. First of all polynomial functions, all trigonometric functions, all exponential, logarithmic are continuous in their domain. Okay, you know domain already, polynomial domain, trigonometrical domain, exponent का domain, सबका domain you already know, right? So they are saying that कि जितने भी functions होते हैं ये सारे के सारे अपने domain में क्या होते हैं, continuous होते हैं. ठीक है. ऊपर से second, we never talk about continuity and discontinuity at a point at which we can't approach from either side of the point. Means what? These points are called as isolated point. Like this is a function root under a minus x and root under x minus a at x equals to a. Means in this case we will not talk about continuity and discontinuity. Why? Because if I will take x is equals to a plus, right? So if I will take a plus, so in this case root x minus a, suppose I have taken x tending to a plus, so it will be root under positive. But if I will take a minus x, definitely it will be root under negative. So this will not be defined now. Okay, suppose we are taking x tending to a minus, then in this case what happened? This will be negative and this will be positive. So in one case one is not satisfying, in other case the other one is not satisfying. So in this case we can't approach from both the side. Okay, so LHL we are getting, RHL we are not getting. In some cases RHL we are getting, LHL is not getting. So that's why in this case we never talk about continuity and discontinuity. We simply say that we can't find, right? So these kind of points are called as isolated points. And also there are some functions which are continuous only at one point. Yani throughout the graph you will find that there is only one point where it is continuous. Like if x tends 0, so this is the function f of x equals to x minus x. If x is a rational number, then it is x, and if x is not a rational number, irrational number, then it is minus x. So only 0 can verify it. Okay, so these are the example you can see. For now you just have to remember that if some function which are continuous only at one point, there are some function which will be continuous only at one point. Okay. Okay, so we will move to the next thing. Okay, so from यहाँ से थोड़ा ज़्यादा मजा आएगा. Already we have discussed this thing, reason of discontinuity through the graph that you have seen. Same thing I am explaining here also once again. First of all, for the reason of discontinuity, that limit around x tending to a doesn't exist. Yani there are 3 points they have given, A, B, and C. You can see around A, If we will go right hand side, there is other value. If you go left hand side, there is other value. So it means what? It means simply the mean is LHL is not equals to RHL. If LHL is not equals to RHL, then we say that the limit doesn't exist. That you already know, that you have studied in the limit chapter. The second thing is, if f of x is not defined at x is equals to b, already that thing also we have seen. You can see at around b, right and left both are equal, but at exactly b we don't have any value. So in this case we can say LHL is equals to RHL, but f of b not defined. So this is also a point of discontinuity, guys. Okay, and then the third point is LHL and RHL is equal. F of C is also defined, but it is not having the value equal to LHL RHL. Means LHL is equals to RHL, and f of C is also defined, but it is not equals to RHL. So these 3 points you need to remember. If you will see all these 3 points from there, you can say that these are the point of discontinuity. Okay, and there is only one condition for the continuity, that is LHL is equals to RHL is equals to f of A at any point. Okay, because if these 3 condition are happening simultaneously, then what we can say that there will definitely be a break between the points. Okay, देख सकते हो, there are a point, ये यहाँ पे भी ब्रेक हो गया, यहाँ पे भी ब्रेक हो गया और यहाँ पे भी ब्रेक हो गया. ठीक है, चाहे अलग अलग कंडीशन ही क्यों ना हो, किसी ना किसी वे में there is a break. So if there is a break, then that point at around this point there is discontinuity. Okay. Okay, so now we will move to the next thing. देखो यहाँ पे ये already हमने discuss किया है. We have discussed this thing like if any function is, so before going to that, let me explain few things. When we talk about continuity, so we talk about continuity at around two ways. First is continuity at a point, and second one is continuity at an interval. What is continuity at a point? Means you have to just check in the neighborhood of that point. Like suppose there is a point A, if we want to check the continuity at point A, so we have to just see LHL and RHL. Okay, like I am saying just simply one example I am taking. Okay, like this, okay, like this, and there is a point C, and I have to find whether the function is continuous at point C or not. So we will not see that key here there is a gap, there is also a gap, this is the point of discontinuity. We will not see. We have to just see the neighborhood, LHL and RHL. So if all are equal, then we will say that yeah, this function is continuous at point C. But I know that at B and C, A, it is discontinuous, but we are not talking about it. So this is called as continuity at point. If you want to find the continuity at point, you just have to find LHL is equals to RHL is equals to f of A. Or otherwise, if it is not any condition is not fulfilled, then we will definitely say that it is not continuous, or you can also say that it is discontinuous. It is either not continuous or somewhere it will be discontinuous. Both are same thing only. Okay, so yeah, so we will see some problems also. Here we have to find the continuity of the function greatest integer function of cos x. There is a function cos x, f of x, and we have to check continuity at x is equals to pi by 2, right? Okay, this is greatest integer function. What I will do, I will simply first find LHL. LHL means what? Limit x tending to pi by 2 minus. So pi by 2 minus means what? Greatest integer function of x, pi by 2 minus of h, right? So if it is pi by 2 minus h, then this is, you can also write na sin h, because cos pi by 2 minus theta is sin theta. And here if it is x tending to pi by 2 minus h, I can also write h tending to 0. Okay, So now this is sin h. If h tending to 0, so definitely it will be 0, almost around 0. It is a positive quantity h is. So we are getting 0, 0 point something, suppose we are getting. But still, what will be the greatest function? It will be 0 only. First thing. Now, the second, we have to find RHL. RHL means what? Limit. Okay. Yeah. This is the same thing that we have explained in the previous thing also. But for that, we have to just check the whether the function is continuous at a point or not. Like LHL is equals to RHL is equals to f of a. Okay. But now we have started continuity at a point. So I have differentiated that ki what is the continuity at a point and what is the continuity in an interval. Okay, interval is different thing that I will explain later. Point is different thing. So in the whole graph, whether there are lots of point of discontinuity, but if someone will ask you at point C whether this function is continuous or not, you have to just check the neighborhood of C, not B and A. We just are concerned with C only. Okay. Okay. Yeah. So now RHL, what we will limit x tending to pi by 2 plus. So now it is cos pi by 2 plus h. Okay, so cos pi by 2 plus theta, you can say that it is minus sin theta. Okay, so or you can also write as now we know that ki sin h tending to 0 and it will be 0, but it not be exactly 0. Something will be there. Because we are limit, we are finding limiting value, not exact value. We are considering that 2, but it is not exactly 2, it is tending to 2. So similarly, so you can say that is minus something positive. So negative of something. So definitely it will be less than 1 now, because sin h value can't be greater than 1. So negative of something, definitely the greatest inter function will be what? It is minus 1. So if it is minus 1, you can see LHL is not equals to RHL. So if LHL is not equals to RHL, so what we can say that this function, greatest integer function of cos x, is not continuous at x is equals to pi by. Is it clear, everyone? Is it clear? JNB, Mahe, Gondia, Rajkot, Porbandar, SKLM. Okay. Yeah. So you just have to find LHL, RHL. Just you should have idea about the limit. That's it. You can solve it. Okay. Like the other thing. So sometimes if you have the command of the graph, so if for discontinuity you can also use the graph also, right? So you know that what are the reasons of discontinuity. Okay, regions of discontinuity. So first of all, I have to check where this function is discontinuous. So first thing what we have to find, I have to check whether this is not defined, because there was a case where it is not defined. So not defined also comes under the reasons for the discontinuity. So first I have to check whether the log x is defined or not. So log x, if it is defined only if x is greater than 0, yani mod x is all greater than 0. But one thing that we can say that there is a point x, mod x is always greater than 0, right? Because it is mod value. But there is a point x is equals to 0. So why I am taking x is equals to 0? Because if you will take LHL, no problem. Okay, if you are taking RHL, there is no problem. But if you have to find f of 0, so how can you take like this 1 by log of 0? It will be not defined now. So LHL, RHL, there is no problem. But if you will find the exact value of f of 0, then it will be not defined, because 1 by log 0 is not defined, right? Because log 0 is not defined, not 1 by log 0. Log 0 is not defined. Okay. Then the other thing is that this log of mod x should not be equals to 0, because if it will be 0, then 1 by 0 is not defined. Okay, because 1 by 0 is not defined. Yani again we have to check ki where log of mod x is equals to 0. So you know that ki if mod x is equals to 1, because log 1 is what? Log 1 is always 0. So log 1 is 0. So again from here we will get 2 point plus minus 1 by plus minus 1. Okay, so if we will take plus 1, so around plus 1, no problem, I can find LHL, I can find RHL. But there is a problem. What is the problem? That exactly if you have to find f of 1, then there is a problem, because if I will find log 1, it will be again 1 by 0 not defined. If I will find f of minus 1, again I can find LHL and RHL. But if I have to take minus 1, I will put again, it will become log 1 and it will become 1 by 0 not defined. So from here, what we have found? We have found 3 points, minus 1, 0 and 1, where the function is not defined. And if the function is at that point is not defined, then we can say that these are the point of discontinuity. Right? So we have not used anything, we have just checked कि कौन से points हो सकते हैं. So there are 3 points where the function is not defined. Okay, is it clear, guys? I hope it is clear. Okay, so any 3 properties you have to just keep in mind and you can find it. Okay, and this is also very easy, because you know that this is fractional part. Okay, so this is fractional part. Okay, x minus greatest integer function of x. So you know that key fractional part of this is always discontinuous at every integer. I think you must have know the graph also. If you know the graph of the fractional part of x, it is like this. At every fractional part, it will be like this. At every fractional part, it is like this. Sorry, integer. This is 1, this is 2, this is 3. At every, there is a point of discontinuity. Okay, so that's why you can directly remember it. Otherwise, you can at every integer point, you can find LHL and RHL. You will find different value. So LHL is equals to not equals to RHL. So just remember this: fractional part and greatest integer function, both are always discontinuous at every integer. Okay, every integer. ठीक है, ये हो गया आपका. And the next one is that there is a function where mod is given, right? Mod x. I am simply telling you the trick. Whenever these kind of function will come, and if somebody will say you that find the discontinuity at find the discontinuity of the function, at what point it is continuous or discontinuous. What you have to do, you just have to find critical point. What is critical points? For this it will be 0, for this it will be 1, and for this it will be 2. Okay, so find critical points first thing. And then what you have to do now? You have to just, because apart from these 3 critical points, everywhere the function will be continuous only. This is common. Why I am saying this? Because apart from these 3 values, if you take any values, so you will get a polynomial function, and polynomial function is always continuous. Okay, then you have to just check the continuity or continuity of the function at these 3 points only, 0, 1 and 2. Only at these 3 points you have to check whether the function is continuous or not. Right? We can check it. So it is not necessary that all 3 points will give you discontinuous point, not like that. It may happen that all these 3 points will be discontinuous, or none of them also. But there is a necessity that we have to check around 0, 1 and 2. And why we are checking? Because you know that around 0, this is changing its color. Color means its nature, like 0 plus pay it will be positive, 0 minus pay it will be negative. So there is a chance that there will be change in functions. Okay, so that's why you have to check around 0, 1 and 2. And if it is you are getting LHL equals to RHL around 0 point, then also at 0 also it is continuous. If you are finding LHL around 1, if it is equal and f of 1k equal, then you can say that yeah, it is continuous. If it is not coming, then you can say it is discontinuous. So you have to check all threes. Okay, not more than that. Okay, now we will see continuity and interval. What is the meaning of continuity and in an interval? So basic meaning of continuity and interval is any function is said to be continuous in an interval, open interval a comma b, if function is continuous at each and every point belongs to a to b. यानी a to b के बीच में there are lots of infinite number of points. And if a function, we are saying that the function is continuous and in interval, like right, like this. Suppose like this. Okay. Suppose like this, and like this is there. Okay, so this is B and this is A. And if I am talking about f of x is continuous in A to B, then I am wrong. Because A to B, there are 2 points, one is C and other one is D. Here there are 2 points, this is discontinuous. So if we are talking about interval, so in between all the points, it should be continuous only, right? If I am saying that there is a point, suppose E, function is continuous at x is equals to E, then yes, it is continuous. Because in this case, we are talking about continuity at a point, and in this case, we are talking about continuity and interval. So in interval, we have to take all the points, we have to consider each and every point between A and B. But in the second case, we are only talking about at E. So at E, we will check for left hand side and right hand side at f of E. So yeah, this is continuous, right? So now I hope you have understood what is the meaning of continuity of interval or point. Okay, now that there is few more thing that it is I hope you have got the open interval wala concept. Now if we are talking about closed interval like A to B, okay, so again A to B, all the points are included, so in between it will be simply f is continuous in open interval. We will check like the previous one, A to B में जितने भी points हैं वो चलेगा. लेकिन we have taken the close interval, right? Just wait for a second, guys. Sorry. Okay, so we have taken a close interval. So A and B is also included. So here you can see the graph here. If I am taking A and B also, so in between I have checked all the points. All the points we have checked the continuity and it is continuous. But what about A? And what about B? Both are included now. So that exception I was talking about, it is there. In this case, what we have to do, you can see around A, there is no LHL, but there is RHL. Around B, there is LHL, yani left hand side, but there is no RHL. Right? So in this way, what we have to do, at A point, what we have to do, there is a new term called as right continuous. Right continuous means what? F of A is equals to RHL. Not LHL, because for A there is no LHL. So if there is RHL, so we will say that f of A is equals to RHL. So this is called as right continuous. Right. Similarly, For B, there is no RHL, but it is LHL. So we can say that LHL is equal to f of B. Okay, so this is called as left continuous because left hand side is there, right hand side is not there. Because it is closed, we can't go beyond B and we can't go this side of A because it is bonded A to B. So we have to just check the continuity at the boundary point. Then we can say that the function is continuous in closed interval. It is similarly as the open interval as well. Both are same, but we just have to check at the boundary point. This is the same, but these 2 points is extra in the closed interval. We have to just check the right continuity at A and left continuity at B. Okay, I hope you have got this. Okay, so one by one, if you will see the question, then it will be more clear. Okay, let's see this question. A function, we have given a function, okay, different function in different interval. So if you will see from minus infinity to 0, okay, in this interval, if you will see what we are getting the function value as 1. So from minus infinity to 0, it is not changing. It is always what? 1. If it is always 1, yani it will always continuous. So no need to check from the minus infinity to 0. But from 0 to pi by 2, from around 0, the function value changed. It was 1 earlier, but now it is 1 plus sine x. So there is a chances that there might have any point of discontinuity. And there is a doubt at x equals to 0, this function might be discontinuous. So at around 0, we have to check, right? And around again from 0 to pi by 2, it is 1 plus sine x, but from pi by 2 again the function is changed. So the basic funda is that you just need to care about the points where the function is changing, and you just have to check the continuity of the function at those points only. So here we can see there are 2 points. At x equals to 0 we have to check, and at x equals to pi by 2 we have to check. Now you can see, sir, maybe there is chances that 0 to pi by 2, maybe this function is discontinuous at some point, but you can see it is 1 and it is sine x. So sine x is always continuous now. I have told you trigonometric function is always continuous in its domain. So it is always continuous. So there is no need of 0 to pi by 2 के between में, ये always continuous होगा. This function is also a polynomial function. This is a quadratic equation. So it is also continuous. So just where the function changes, you have to check. So at x equals to 0, if I will check LHL. So LHL limit x tending to 0 minus the function value is what? 1. Okay. If I have to find RHL, it is 0 plus. So it is 1 plus sine 0 plus h. So 1 plus sine h tending to 0. So it is 1 plus sine 0. So it is 1 only. And again, if we have to say f of 0, so f of 0 means what? At exactly 0, it is 1 plus sine 0. So it is 1 plus 0. So it is 1. It means what? At x equals to 0, what we can say that LHL is equals to RHL is equals to what? F of 0. So it means at this point it is continuous. Okay, now at x equals to pi by 2. Yani there were chances, but we found out that no, at x equals to 0 also it is continuous. ठीक है. अब at x equals to pi by 2 पे देखो LHL limit x tending to pi by 2 minus, it is 1 plus sine pi by 2 minus h. So it is 1 plus cos h, and h tending to 0, it is 1 plus cos 0 means 1. So 1, 1, 2. Similarly, I have to take RHL. If I would take to RHL, it is x tending to pi by 2 plus h. Right. So pi by 2 means now we have come into this interval, and for this is the function. So what it will be? 2 plus pi by 2 plus h minus pi by 2 ka whole square. So 2, this will be cancelled with this. It is h ka whole square. So this is 2 plus h square and 2 plus 0 square, it is 2 only. And similarly, if you find f of pi by 2, so what is the f of pi by 2? It is again 2 plus pi by 2 minus pi by 2 ka whole square. So again it is 2 plus 0 ka whole square, it is 2 only. So again here you can see it is continuous only, because LHL is equals to RHL is equals to f of pi by. Okay, so there were chances that in these 2 points it can be discontinuous, but we have found after finding LHL RHL value that it is continuous at the both point. So now we can simply say that from minus infinity to infinity this whole function is continuous. Okay, because minus infinity to 0 there is no need to check. From 0 to pi by 2 there is no need to check. From pi by 2 to infinity there is no need to check. We just need to check at the boundary points. Okay, you have to just check at the boundary points. I hope you have got it. Is it clear, everyone? Janbi, Porbandar, Rajkot, Mahe, SKLM. Okay, chalo. Okay, so these are the things that I have already explained in the classes also. Aji ke class mein. Like simple things is that every polynomial is continuous, every rational function is continuous, but we should be care about the denominator can't be 0. All logarithmic, exponential, trigonometric, inverse, modulus function are continuous only, right? And if two functions are continuous, then the sum of two functions, and difference of two continuous function, product of two continuous function, and division of two continuous function will be also continuous function. Okay, just we need to care that if it is divided, then the denominator part should not be equals to 0. Okay. Okay, then also I have told you the greatest integer function is always discontinuous at what? Integer point. And if any function is continuous at any point and other function is continuous at g of a, so we can say that f of g, any composite of that function is also continuous at x equals to a. Okay, and f of g means what? F of gx. Okay. And then this point, 7th number point, is very easy. What they are saying, if any continuous function is there such that there are 2 points a to b, right? And f of a and f of b are of opposite sign. Means if f of a is positive, so f of b is negative. Like suppose this is a and this is b. So f of a, you can see it is positive, and f of b is it is negative. So if both are opposite sign, then they are saying that if it is a continuous function, so there is at least one point it will be in the a to b interval where the function value vanishes. Function value vanishes ka matlab f of x is equals to 0, because it is obvious now. If function is positive and after that it is negative, so in between there will be must value where it cross 0, right? Otherwise positive से direct negative आएगा तो obvious है उसको discontinuous होना पड़ेगा, और अगर वो कंटिन्यूअस के साथ आ रहा है तो उसको 0 तो क्रॉस करना पड़ेगा. ठीक है, इट मीन सपोज हम अगर कहीं पे जा रहे हैं, एक प्लेस से दूसरे प्लेस से जा रहे हैं, अगर मुझे घर से बाहर निकलना है तो ठीक है, तो मैं शक्तिमान तो नहीं हूं कि यहीं पे गायब हो गया और उसके बाद कहीं पे चला गया. अगर मुझे जाना है किसी प्लेस पे तो फर्स्ट आई हैव टू क्रॉस टू माय डोर्स, राइट? मुझे खोलना पड़ेगा तो जाना पड़ेगा. तो जस्ट लाइक दैट ओनली यू कैन अंडरस्टैंड. ओके, लाइक मैं उड़ के कहीं तो नहीं जा सकता हूँ, मुझे रास्ते से ही जाना पड़ेगा ना. तो वही बातें है. तो डिसकंटिन्यूअस की नहीं, यहाँ पे ऑलरेडी स्ट्रिक्टली इट इज मेंशन दैट द फंक्शन इज कंटिन्यूअस. इफ इट इज कंटिन्यूअस देन डेफिनेटली इट शुड क्रॉस अ पॉइंट दैट इज 0. ठीक है, बिकॉज ये पॉजिटिव. और ऐसा भी हो सकता है कि अगर नेगेटिव है और फिर पॉजिटिव है, तो इस केस में भी नेगेटिव से पॉजिटिव के लिए इसको 0 को क्रॉस करना पड़ेगा. ओके, सो these are the points. So these are the very important results that you have to remember always. whenever you are getting any kind of fractional part function or greatest integer part of function, you have to check the continuity at all points जहां पे ये जो अंदर का फंक्शन है वो इंटीजर बने, ठीक है, क्योंकि और जगह पे कोई प्रॉब्लम नहीं होता, यू वोंट बी हैविंग एनी प्रॉब्लम, बट at integer point there must be a problem because at integer it is changing. So that's why you just be aware that you make sure that you have to check whenever you are getting any kind of signum function. Okay, so signum function mein you have to check this function should be always equals to 0. So at those point you have to check the continuity. Okay, and then also this point I have also discussed that if we are checking the continuity of any function, so it should be checked at point where definition of function changes, where the function is changing from one type to another type, like 1 to 2 it is sin x, and from 2 to 3 it is log x plus 2. So function changes now, so at those boundary points you have to check the continuity of that function. Okay, and the last one is continuity of a function should be checked at end points, because we are talking about interval. So if we are talking about interval, then we have to also check at the end point a and b. The last case is minus infinity to infinity, and we were very sure that if it is coming from minus infinity, so it is always 1, so we haven't checked it, but you have to check the end point also. Okay, so yeah, so these are the simple points like that we have already discussed. Same thing, third point, first point we have discussed, second point also. And also one thing you have to remember that if function is continuous on a to b, then inverse of that function is also continuous. Okay, so one question I am just explaining, and then after that we will finish the class, guys. Okay, you can see here what it is saying, that determine the value of a so that function is continuous at x equals to 0. This kind of problem will come in your J exam. They already said that if function is continuous at x equals to 0, at x equals to 0, f of x is continuous. So find the value of a. So what we have got from here, if it is continuous, then definitely LHL will be equals to RHL, and it will be equals to f of 0. So there is one variable. What is that variable? That is a. So what I have to do, we have to simply first do nothing, just find LHL. So if I will find LHL, it will limit of x tending to 0 minus. If it is 0 minus, definitely this function will become. So 1 minus cos 4, in place of x I will write 0 minus h and 0 minus h ka whole square. So it will be 1 minus cos 4h divided by h square. Now it is just a case of limit only. So 1 minus cos 4h divided by h square. So what I will do, you know that 1 minus cos 2 theta is equals to 2 sin square theta. You know that I have already explained in the previous class. Whenever you see these kind of thing in the limit, just convert into 2 sin square theta. So it is 2 sin square. In place of theta, what I am writing 2h, because if it is 2 theta, it is becoming theta. So if it is 4h, so it will be 2h, and this is h square. But the problem is that it is sine of 2h ka whole square. So I have to make this 2h ka whole square so that I can use sin h by h. So what I am doing, I am simply multiplying and dividing with 4. So it will be 2 into 4, and it will be 4h square. I can write 2h ka whole square so that I can write it like this: 8 into sine 2h divided by 2. I am just adjusting the value. Okay, so now here you can see this value is what? It is 1. So it is 8 into 1 ka whole square. So it is 8 only. So LHL we have got as 8. Okay, no problem. This is a simple limit that we have used. We have simply put 0 minus h, and after that we have got this one where limit h tending to 0, and then we use the limit. Okay, and you know that f of 0 value is given as a only. Okay, you can see here also f of 0 is a only. So from here also, what we have got, we have already got f of 0 is equals to LHL because it is continuous. So from here we can directly write a is equals to 8. Okay, so no need to find RHL because it is continuous. So definitely RHL will be also equals to 8. But for the verification, I am just finding RHL also, right? That it should be 8 or not. And then, so RHL. RHL means what? It is limit h x tending to 0 plus. So it is 0 plus h or h tending to 0. So root x divided by root 16 plus root x minus 4. Okay, so what I am doing, guys, first of all, if you see in the limit, then we can use it whenever you see these kind of thing. What you can use? You can use rationalization here. So I am using rationalization. Okay, so after that, what we will get? This is root x. This is 16 plus root x plus 4. And here you can see it is a and this is b. This is a and this is b. So after a plus b into a minus b, it will be a square plus b, a square minus b square. It will be 16 plus root x and minus 4 ka whole square. So it will be root x and then it is 16 plus root x plus 4. Okay. It will be null, simply doing the calculation, nothing more than that. Okay, and then it is 16 and minus 16, it will be plus, cancel out root x, root x, root x, root x will be cancel out. So what we have left with? We have left with root 16 plus root x plus 4. So what I can write here? I can write here limit h tending to 0, then it is root under 16 plus root x, means x is what? 0 plus h, it means it is h, and then plus 4. So if h tending to 0, it is root 16 plus 4, so it is 4 plus 4, so that is equals to 8. So now you can say we can verify that yeah, it is also 8. So yeah, definitely they have already told that it is continuous, so no need to find it. But for the verification, we have found that. But sometimes there will be two variable a and b. So for that, if you will find something equate to something, it will be one equation. Then by using RHL, you can find another equation. After solving those two equations, you will get a and b. We will see those kind of problem also. So that's it for the hello. Okay, so after that, in the next class, we will see types of discontinuity. Okay. Okay, we have already seen those types, right? But there is a naming like removable discontinuity, non-removable discontinuity, missing point discontinuity, isolated point discontinuity. You have already seen all these things while explaining the graph. But for every particular discontinuity, there is a name. Okay, so I will explain those things. And after that, there are some theory also left. And then I will start the differentiability. Okay, so just be there in the tomorrow's class also. I hope maybe this week there will be no test. So tomorrow will also be a proper classes. Okay, so that's it for the today's class, guys. If you are having any problem, just let me know through the chat box. Thank you.